Report on the release of China's DeepSeek-R1 AI model. Introduction. On January 20, 2025, the Chinese tech startup DeepSeek launched its latest large language model DeepSeek-R1, which has quickly gained traction in the global AI community. This model not only matches the capabilities of established competitors like OpenAI's O1 but does so at a fraction of the cost, raising eyebrows and concerns among industry leaders in Silicon Valley and beyond. The release of DeepSeek-R1 is seen as a significant milestone in the ongoing competition between U.S. and Chinese AI technologies. Background. DeepSeek, based in Hangzhou, China, emerged into the spotlight in December 2024 when it introduced DeepSeek v3, which was benchmarked against major models like OpenAI's GPT-4o and Anthropic's Claude Sonnet 3.5. The performance of DeepSeek v3 quickly established the company as a significant player in the AI landscape, especially given its cost-effective development. DeepSeek-R1 builds on this success, showcasing the company's ability to produce competitive AI models under constraints such as U.S. export restrictions that limit access to high-performance AI chips. Notably, DeepSeek utilized only 2,000 GPUs to train DeepSeek-R1, significantly fewer than the 10,000 GPUs reportedly used by OpenAI for its competing models. Key features of DeepSeek-R1. 1. Performance. Initial tests indicate that DeepSeek-R1 performs on par with or surpasses the reasoning capabilities of OpenAI's O1 in tasks such as chemistry, mathematics, and coding. This is particularly noteworthy as reasoning models utilize a chain-of-thought approach, allowing for more effective problem-solving compared to traditional models. 2. Cost efficiency. The training costs for DeepSeek-R1 are estimated at around $6 million, which is approximately one-tenth of what companies like Meta reportedly spend on similar projects. Moreover, users can access DeepSeek-R1 for about 27 times less than the cost of using OpenAI's O1, making it an attractive option for researchers and developers with limited budgets. 3. Open-weight model. Unlike many proprietary models, DeepSeek-R1 has been released as an open-weight model, allowing researchers to examine and modify its underlying algorithm. While the training data remains undisclosed, this level of transparency is a significant advantage over many Western models often criticized for being black boxes. 4. Resource efficiency. Built under stringent export restrictions, DeepSeek's development approach emphasizes efficiency, managing to create a competitive model while using significantly fewer resources. Reactions and industry implications. The introduction of DeepSeek-R1 has sparked a mix of excitement and anxiety within the AI community. Prominent figures including Microsoft CEO Satya and Nadella have acknowledged the need to take Chinese AI advancements seriously, suggesting that the landscape of AI innovation may be shifting dramatically. This sentiment reflects a growing concern in Silicon Valley about the potential for Chinese technology to redefine competitive dynamics in AI. Experts note that DeepSeek's success illustrates the resourcefulness of Chinese developers in navigating technological limitations. Some analysts argue that the U.S. should consider collaborative approaches to AI development rather than fostering a competitive arms race which could potentially stifle innovation on both sides. Common themes in coverage. Reports on DeepSeek-R1 consistently highlight its comparable performance to OpenAI's models, emphasizing its cost advantages and the benefits of its open-weight structure. The contrast between DeepSeek's approach and that of many Western companies is frequently noted, particularly in discussions about transparency and accessibility in AI research. Differences in coverage. While some media outlets focus on the technical specifications and performance benchmarks of DeepSeek-R1, others, particularly from Chinese sources, emphasize the geopolitical implications of its development. This framing positions DeepSeek's advancements as a challenge to U.S. technological dominance, suggesting that the landscape of global AI innovation is changing. Conclusion. DeepSeek-R1 represents a significant technological achievement and a shift in the competitive AI landscape. Its release has the potential to alter the dynamics between major players in the industry, particularly as it demonstrates that high-performance AI can be developed more affordably and transparently. The model's success may encourage further innovation and collaboration in the field, challenging existing paradigms and prompting a re-evaluation of strategies among U.S. tech companies. As the global AI landscape evolves, the interplay between competition and cooperation will likely define the future of artificial intelligence development. Counterintuitive insights from the launch of DeepSeek-R1. The introduction of China's DeepSeek-R1 large language model (LLM) has been met with a mix of excitement and apprehension in the global AI community, particularly in Silicon Valley. It challenges established norms and expectations surrounding AI development, especially when compared to Western counterparts like OpenAI's models. Here are several counterintuitive points derived from the feature's implications and reactions surrounding DeepSeek-R1. 1. Cost-effectiveness over computational power. One of the most striking aspects of DeepSeek-R1 is its performance achieved at a fraction of the cost and resources typically required by Western models. While it is commonly assumed that superior AI capabilities necessitate vast amounts of computational power, often measured in high-end GPUs, DeepSeek's success with only 2,000 GPUs compared to the 10,000 used by OpenAI forces a re-evaluation of this belief. This suggests that efficiency and innovative algorithm design can compensate for a lack of raw computational horsepower, defying the conventional wisdom that bigger is always better in AI. 2. Open-weight model versus closed ecosystems. DeepSeek-R1's release as an open-weight model contrasts sharply with the proprietary nature of many Western AI systems. While the expectation is that more open systems might lead to less robust security or intellectual property concerns, DeepSeek has garnered praise for its transparency and adaptability. This openness allows researchers and developers to scrutinize, modify, and improve upon the model, fostering a collaborative ecosystem that some might argue could lead to faster innovation than the closed systems typically favored by Western companies. 3. Geopolitical implications of AI development. The reaction from Silicon Valley, including comments from leaders like Microsoft's Satya and Nadella, illustrates a growing concern that a Chinese company could challenge U.S. dominance in AI technology. Traditionally, it is assumed that U.S. technological superiority is unassailable due to its extensive resources and access to top-tier talent. However, the emergence of DeepSeek suggests that geopolitical barriers such as export restrictions on AI chips can inadvertently stimulate greater innovation and resourcefulness in competing regions. This flips the narrative. Rather than stifling competition, restrictions may catalyze unexpected advancements in adversarial regions. 4. The role of collaboration in competitive markets. Despite the competitive narrative between the U.S. and China, some experts advocate for a collaborative approach to AI development. The assertion that the U.S. might benefit from working with Chinese developers instead of viewing them solely as competitors challenges the binary perspective of international relations in technology. This perspective emphasizes that shared innovations could lead to mutual benefits, which is often overlooked in favor of a more adversarial view of technological advancement. 5. Perceptions of AI capabilities. DeepSeek-R1's capabilities in reasoning and problem-solving tasks have been reported to match or exceed those of established models like OpenAI's O1. This challenges the belief that newer entrants in the AI field cannot surpass the benchmarks set by industry giants. The implication is that perception and reality in AI capabilities can be misaligned. Just because a model comes from a lesser-known company does not mean it is inferior. This could lead to a reassessment of how emerging technologies are valued and recognized within the global tech landscape. 6. Impact of resource constraints on innovation. The fact that DeepSeek developed a highly competitive model under U.S. export restrictions highlights a counterintuitive dynamic. Limitations can drive innovation. Instead of viewing resource constraints as a hindrance, they can be reframed as a catalyst for creative problem solving. This challenges the notion that unrestricted access to resources is a prerequisite for breakthrough innovations, suggesting that adversity can spur ingenuity and lead to unexpected achievements. 7. The future of AI accessibility. DeepSeek-R1's cost structure, 27 times cheaper to use than OpenAI's O1, raises questions about the accessibility of advanced AI technologies. It contradicts the assumption that only well-funded organizations can leverage cutting-edge AI models. With models like DeepSeek-R1 being accessible to a broader range of researchers and developers, this could democratize AI innovation and application, potentially leading to a surge in diverse AI solutions that might not emerge from traditional funding avenues. Conclusion. The emergence of DeepSeek-R1 exemplifies how the landscape of artificial intelligence is shifting, and it highlights several counterintuitive insights that challenge long-standing assumptions about cost, access, and competition in AI development. As researchers and industry leaders grapple with these new realities, the implications for future collaborations, competitive strategies, and the global balance of technological power will continue to unfold, making it imperative to reassess the frameworks through which AI advancements are understood and engaged with. The report on China's DeepSeek-R1 model highlights several critical aspects that are likely to be overlooked by many readers, yet they carry significant implications for the future of artificial intelligence, AI, and international technological competition. Here are these overlooked elements and their importance. 1. Open-weight model significance. While many reports mention that DeepSeek-R1 is an open-weight model, the implications of this feature are often underexplored. The ability for researchers to analyze and modify the underlying algorithm is crucial for fostering innovation and collaboration in the AI community. This openness contrasts sharply with the proprietary nature of models like OpenAI's O1, which are often seen as black boxes. The significance here lies in the potential for a more collaborative research environment that could accelerate advancements in AI technology, particularly in fields where transparency is vital for credibility, such as healthcare and environmental science. 2. Cost efficiency and accessibility. The striking cost efficiency of DeepSeek-R1 being 27 times cheaper than its U.S. counterparts is noted, but its broader implications are frequently overlooked. This affordability could democratize access to advanced AI tools for researchers and institutions in developing countries or smaller organizations that traditionally lack the capital to access cutting-edge technology. By lowering the barrier to entry, DeepSeek could foster a more diverse range of innovations and applications across different sectors, potentially leading to breakthroughs that would not have been possible in a more restricted environment. 3. Impact of U.S. export controls. The report briefly mentions the U.S. export restrictions that have limited Chinese access to high-performance AI chips, but it does not delve into how DeepSeek's success under these constraints could reshape perceptions of technological capabilities. The ability of DeepSeek to produce a competitive model with significantly fewer resources challenges the notion that advanced AI development is solely dependent on access to the latest hardware. This could lead to a re-evaluation of strategic priorities in both the U.S. and China regarding AI development, emphasizing efficiency and innovation over sheer computational power. 4. Geopolitical implications. The emergence of DeepSeek-R1 in the context of U.S. China relations is significant but often receives cursory treatment. The model's capabilities could alter the balance of power in AI technology, prompting a reconsideration of competitive strategies. As U.S. companies feel pressure from this new competitor, the potential for collaboration versus competition in AI governance and development becomes critical. This could lead to new frameworks for international cooperation in AI, which is particularly relevant given the global nature of technological challenges like climate change and public health. 5. Cultural and ethical considerations. The open-source nature of DeepSeek-R1 raises questions about the ethical implications of AI development. The report does not fully explore how an open model can enable a more inclusive dialogue around AI ethics, safety, and governance. As more researchers from diverse backgrounds engage with an open model, the conversations around the ethical use of AI, addressing biases, accountability, and transparency, could evolve. This could lead to more robust ethical standards that might be adopted globally, contrasting with the often insular discussions that occur around proprietary models. 6. Innovation under constraints. The report highlights DeepSeek's ability to innovate despite limitations imposed by external factors such as chip restrictions. This aspect is significant as it showcases the potential for creativity and resourcefulness in technology development. The narrative that emerges here is one of resilience, how companies can thrive under pressure and develop effective solutions to complex problems. This could serve as a model for other industries facing similar constraints, encouraging a mindset of innovation that prioritizes efficiency and adaptability. 7. The future of AI development dynamics. The implications of DeepSeek-R1 extend beyond immediate competition. They suggest a potential shift in the dynamics of AI development itself. If DeepSeek continues to succeed, it may encourage a move away from traditional funding models and resource allocation strategies that prioritize large-scale investments in hardware. Instead, there could be a growing emphasis on software efficiency, algorithmic innovation, and collaboration, which could democratize AI research and application. Conclusion. In summary, while the report on DeepSeek-R1 captures the excitement surrounding its launch and its capabilities, it underemphasizes several crucial aspects. These include the significance of its open-weight model, the ramifications of its cost efficiency, the impact of U.S. export controls, the geopolitical implications, cultural and ethical considerations, and the potential for innovation under constraints. Understanding these elements is essential for grasping the broader implications of DeepSeek-R1 on the global AI landscape and the evolving dynamics between the U.S. and China in technology development. 1. Performance and reasoning capabilities. DeepSeek-R1 has demonstrated performance levels that are comparable to or exceed those of established models like OpenAI's O1 in critical domains such as chemistry, mathematics, and coding. This is particularly noteworthy because DeepSeek-R1 employs a chain-of-thought approach similar to the reasoning models developed by OpenAI. This capability allows it to tackle complex problems more effectively than traditional language models, making it a promising tool for researchers and professionals in scientific fields. 2. Cost efficiency. One of the most significant advantages of DeepSeek-R1 is its cost efficiency. The training costs for its predecessor DeepSeek V3 were around $6 million, which is substantially lower than the costs incurred by leading competitors. Moreover, the operational costs associated with utilizing DeepSeek-R1 are reported to be 27 times cheaper than those for O1. This lower cost structure greatly enhances accessibility for researchers and institutions with limited budgets, potentially democratizing access to advanced AI technologies. 3. Open-weight model. DeepSeek-R1 is released as an open-weight model, allowing researchers to examine, analyze, and modify the underlying algorithms, although the training data remains undisclosed. This contrasts sharply with the black box nature of many Western models, fostering a collaborative and transparent research environment. The open-weight aspect encourages innovation and adaptability, enabling users to tailor the model to their specific needs and enhancing the overall AI research ecosystem. For resource efficiency and geopolitical implications. Despite facing stringent U.S. export restrictions that limit access to high-performance AI chips, DeepSeek successfully developed its model using significantly fewer resources, only 2,000 GPUs compared to the 10,000 used by OpenAI. This achievement signifies not only a technical breakthrough but also a strategic maneuver in the ongoing geopolitical competition in AI technology. Experts have noted that the emergence of DeepSeek-R1 may signify a narrowing of the technological gap between China and the U.S., prompting discussions about the need for collaborative approaches to AI development rather than a competitive arms race. 1. The Cold War arms race. During the Cold War, the United States and the Soviet Union were engaged in a fierce competition to develop nuclear weapons and other advanced military technologies. The U.S. initially had an advantage in nuclear capabilities, but the Soviet Union rapidly developed its own arsenal, including intercontinental ballistic missiles (ICBMs) and nuclear submarines, leading to a tense standoff. The competition led to significant advancements in technology and military strategy, paralleling the current AI race where nations strive to outperform each other in capabilities and innovation. 2. The space race. The space race between the United States and the Soviet Union in the mid-20th century is a historical example of technological competition. It was marked by rapid advancements in space technology and exploration, culminating in significant milestones such as the launch of Sputnik by the USSR in 1957 and the U.S. landing on the Moon in 1969. Similar to DeepSeek-R1's emergence in the AI landscape, both nations were driven by national pride and the desire to demonstrate technological superiority, showcasing innovations that would have lasting impacts on science and technology. 3. The rise of Japan's electronics industry in the 1980s. In the 1980s, Japan's electronics firms such as Sony and Panasonic emerged as formidable competitors to American companies like IBM and Microsoft. With a focus on innovation, cost efficiency, and high-quality products, Japanese firms began to dominate the global electronics market. This shift led to significant concern in the U.S. about losing its technological edge. The competition pushed American companies to adapt and innovate, reflecting the dynamic scene in the current AI landscape, with the rise of DeepSeek-R1 challenging established giants like OpenAI. The emergence of China's DeepSeek-R1 as a formidable player in the artificial intelligence AI landscape has significant implications for the future of global AI development. Released on January 20, 2025, this large language model (LLM) is capturing attention not only for its competitive performance but also for its cost efficiency and open-source approach, challenging existing paradigms in AI technology dominated by Western firms, particularly in the United States. Key predictions for the future. 1. Increased competition in AI development. The success of DeepSeek-R1 signals a shift in the competitive dynamics of AI development, particularly between the U.S. and China. As more countries and companies observe the cost-effective and high-performance capabilities of models like DeepSeek-R1, we can expect a rise in similar initiatives globally. This may lead to an arms race in AI innovation, with nations investing heavily to develop competitive models. 2. Shift towards open-source AI models. The open-weight nature of DeepSeek-R1 allows researchers to examine and modify the model, potentially leading to a paradigm shift in AI development. As more organizations recognize the benefits of open-source models, we may see a broader acceptance and adoption of similar frameworks, fostering collaboration and innovation in AI research. 3. Impact on research and development. With DeepSeek-R1's performance on par with or exceeding that of established models like OpenAI's o1, researchers and industries with limited budgets will likely gravitate towards this cost-effective solution. This could democratize access to advanced AI technologies, enabling smaller firms and academic institutions to participate in AI research and application development. 4. Geopolitical implications. The rise of DeepSeek-R1 could exacerbate geopolitical tensions, particularly around technology and trade. As the U.S. seeks to maintain its technological supremacy, we might see an escalation in export controls and trade restrictions aimed at hindering China's advancements in AI. Conversely, China may respond with increased investment in self-sufficiency in AI technologies. 5. Collaborative approaches to AI governance. Given the potential for significant breakthroughs from both the U.S. and China, there is an opportunity for collaborative approaches to AI governance. As the global AI landscape evolves, stakeholders may recognize the necessity of establishing international norms and standards for AI use, focusing on ethical considerations and safety measures. 6. Evolution of AI applications. The capabilities demonstrated by DeepSeek-R1 in reasoning tasks could catalyze the development of new applications across various sectors, including healthcare, education, and engineering. As AI becomes more integrated into problem-solving roles, industries may witness a transformation in how tasks are approached and executed, leading to increased productivity and innovation. 7. Long-term technological advancements. The resource-efficient development of DeepSeek-R1 under U.S. chip export restrictions suggests that future AI models may prioritize efficiency and adaptability over sheer computational power. This could inspire a new wave of AI research focused on creating models that can operate effectively within constraints, potentially leading to breakthroughs in energy efficiency and sustainability in AI training and deployment. 8. Potential for AI hallucinations and ethical concerns. As AI models grow more complex and capable, the challenge of managing phenomena such as AI hallucinations, where models generate incorrect or misleading information, will become more pronounced. The industry will need to invest in developing robust mechanisms for error correction and transparency to ensure AI technologies are reliable and ethical. Conclusion. The release of DeepSeek-R1 is more than just a technological milestone. It represents a potential turning point in the global AI landscape. As countries and companies navigate the complexities of competition, collaboration, and ethical considerations, the future of AI will likely be characterized by a rich interplay of innovation, accessibility, and geopolitical strategy. The ongoing developments in this field will require vigilance, adaptability, and a commitment to fostering a collaborative environment that benefits society as a whole.